I'm the co-director of the Social Media Lab. I'm here with Dr. Anatoly Gruz, our Director of Research and a Canada Research Chair in Privacy Preserving Digital Technologies, and Alyssa Saifu, a PhD candidate at Rising University and a research assistant at the Social Media Lab. Before we get into today's topic, I have a few housekeeping announcements. If you missed the first 4 sessions, let's see. All the videos and slides from past sessions are available online at Communalytic.com. Also, just as a reminder, we've created a new Communalytic discussion group on Google. This is where you can post your questions about Communalytic. If you have not already signed up, please do so today. Also, our next and last session in this is in 2 weeks. If you need to leave early today, no worries. The videos from today's session will be available on Communalytic.com by the end of the day tomorrow. This bootcamp series is focused on how to use Communalytic in an academic setting. For those of you who've joined us today for the first time, Communalytic is a research tool for studying online communities and online discourse. For some researcher, all they want to do is have an easy way to collect data and then use other tools to analyze the data. For other researchers, they want a more comprehensive tool that can also help them to analyze the data. Communalytic can do both. It can collect, extract, analyze, and visualize public data from various social media platforms. We designed it so that it can be used by researchers from a wide variety of disciplines. There are 2 versions of Communalytic, the EDU and Pro. The EDU version is designed for students and is ideal for teaching and learning about social media analytics. The Pro version is designed for academic researchers and it's ideal for large-scale academic research projects. The main difference between the 2 versions is the size and the types of data you can collect. So for example, with the EDU version, you can collect up to 30,000 records shared across 3 data sets. With the Pro, you can collect up to 10 million records shared across 50 data sets. And with the Pro, you can also collect historical data. With the EDU, you can only collect live, for example. And
on Twitter.
On Twitter, yes. And then with Communalytic Pro, you get full archive historical research if you also have access to the Twitter academic track. So those are some of the main differences, it's the size and the type of data you can collect. Communalytic EDU and Pro come with the same analytical modules or features. There are 3 main analytical modules in Communalytic. The exploratory data analysis module, which gives you things like an emoji cloud, word cloud, time series, and top posters example from your data set. And then there's the text analysis module, which does toxicity analysis based on a machine learning API from Google. And then there's the built-in network analysis and visualization module, which we're going to go over in more details today. And with both, you can run multiple data collectors. So this way you can just, for example, collect something from Reddit and then use the same keyword or similar keyword terms to search and capture the same data set on Twitter if you want to do a comparative studies, for example. And with both, you can import your own data set. So if you have an existing data set that you have gotten from colleagues or from some other ways, you can import that into Communalytic. And the other thing is that there's lots of collaboration-friendly features. So if you have a large team, you can share data set to your team members. So this way they can see the analysis that you've already ran so that you can analyze the data set together. So for today's agenda, we're going to divide into 3 parts. The first part is going to be taken care of by me. We're going to quickly walk through, for those of you who are not familiar with social network analysis, I'm just going to do a quick primer. Then Anatoly is going to get into more details about analyzing signed networks in Communalytic. And then our research assistant, Alyssa Saifu, will be talking about exporting and analyzing network in third-party programs like Gephi, because we realize that for some certain type of analysis, our tools can't do everything. So you can always export it out and use third-party tool like Gephi. So how do we normally collect information about social network? The most common approach for collecting social network data is self-reported social network data or surveys and interview. Here's an example or a sample question. Please indicate on a scale of 1 to 5 your friendship relationship with each student in the class. So the respondent would have to check and select from one of these choices. But the problem with surveys and interviews is that it's time consuming. The question can be too sensitive, and the answer from the respondent can be very subjective and incomplete. Also, participants can forget people and interaction. They don't remember who they talk to or how often they talk to them. And different people perceive events and relationship differently. This is one of the benefit of using public social media data is it solves many of the problems associated with surveys and interviews for getting network data. So the problem now is how do we make sense of the vast amount of social media data that we're creating? So one of the ways that we and others researchers have turned to is social network analysis. But to understand how to use social networks, I want to go over some basic concept from SNA that you'll need to know. So in SNA, there are three basic concepts. There are nodes, which are the accounts, such as the companies, government department, organization, as an example, or people. There are edges, which are any type of relations, retweet, replies, mention, etc. And the tie strength, the strength of the ties that connects them, the number of retweets, number of replies, and mention. So those are some basic concepts, node, edges, and tie that you have to understand. So for example, to represent a single tweet as a network, first we need to examine who sends it. For example, this is a sample tweet posted by Donald Trump. We can visualize it as a simple network with 3 nodes and lines going from Trump's account to Justin Trudeau and to the White House account, because both are mentioned in the tweet. There are many advantages to using social network analysis to examine data from social media data. After developing the network, you can answer numerous in-depth and follow-up questions such as, how many people interact with each other? Who's the most or least frequent actor? Who's influential in the conversation? Who is susceptible to or open to being influenced? Different types of interaction on social media may produce different network configurations. Here are 3 examples that I'm going to quickly run through. So the first one is an example of a news sharing network from a single source on Twitter. As more and more people retweet the news story from The Guardian, for example, about the Euromaidan revolution in Ukraine, their retweeting behavior forms something that we call would be a star-shaped network configuration with the newspaper account at the center of the network. The next is a slightly more complex network. This is a network representation of a Twitter discussion of a Netflix show called 13 Reasons Why. Similar to the previous example, the initial information diffusion start with the official account for the show. But as the show touches on so many different sensitive topics, such as suicide, mental health, sexual assault, the discussion went beyond what happened on the show. Different group of people with a variety of related interests broke off and started having their own separate discussion. So you can see that visually in the network, it's represented by the long tail structure in this network. So the show main account launched the conversation, but soon people basically digressed and took the conversation in a different direction. But it shows you how engaged a conversation can be based on the original content. The final example is an example of a more complex communication network. This is a network representation of a Twitter discussion about the 2012 Olympics. The Olympics is international in scope, so it tends to attract a more diverse audience than, let's say, the TV show that I just showed you earlier. As a result, this network is made up of many different clusters of nodes. The thing that tied them all together is their interest in the Olympics. But as you can see, each cluster is interested, for example, with the Olympics, a different sport. So they're all interested in the Olympics, but there's a specific aspect of the Olympics that they are interested in. So as a result, when we visualize that conversation as a network, this is something that you would get with the various clusters. There are 2 main categories of SNA measures: micro level measures, which are basically individual node level metrics, and macro measures, which tells you about the network as a whole. Due to time limitation, I'll quickly go over a few of the micro level measures just to give you a sense. So for example, we capture a small data set of tweets about Hong Kong back in 2015. And then we turn that data set into this network representation. So what does network representation tell us? Well, there are different metrics, micro level metrics that we can use to help us understand and basically read the network, as it were. For example, in degree suggests prestige or highlighting frequently mentioned or replied Twitter user. So here's an example of an account with high in degree centrality in the Hong Kong Twitter network from our data set. So it's basically it's featuring one of the South Korean boys band formed by Pleiades Entertainment. It has high in degree centrality in this network. Another type of micro measure is out degree, which reveals the active Twitter user with good awareness of others in the network. This is basically your broadcaster, somebody who is aware of the other players in the network and is sharing a lot of information in the network. So in our data set, that account is Dragon Fleur, but there are many accounts that have high out degree centrality. But for this example, it's a music fan. This person share a lot of retweets and replies to other. And another measure is betweenness, which shows the actor that are located at the greatest number of information path, who often connects different groups of users in the network. So in our example, it's another fan account. But as you can see, this account connect two different clusters. So for example, if this person wasn't in the conversation, these two clusters would not normally have any connection to each other. So this becomes like a bridging agent. Think of this as like a lunchroom in high school where you have somebody who is part of on the football team, but is also part of, let's say, the theater club. They are able to carry information from one cluster to another. If that person is not in the network, these networks basically are insular. So they play an important role within the network. You can learn more about social network analysis. Here are two suggested beginner guides to help you get started. Social network analysis, an introduction by Alyssa Marin and Barry Wellman. And then an easy to consume one is how to get started with social network analysis, a complete beginner's guide. We'll post these slides afterwards so you can have these links, so there's no need to copy them. So next I'm going to turn this over to Anatoly, and he'll go over analyzing sign networks in Communalytics. If you have any questions for me, you can wait to the end, or you can put them into the chat. Thank you.
Thank you, Philip. And before I start, any questions for Philip? All right, there are no questions yet, and so I'll continue. Can I just do a quick audio check and video check? Can you see my slides? Can you hear me okay? Yes.
Yep.
Thank you. So what I want to do is to build on Philip's basic concepts of social network analysis and to introduce this concept of signed networks, signed social networks. The general idea is that if we're able to incorporate more information about the nature of interactions into the network structure, then we will be able to answer a wider range of research questions. So signed networks are networks with positive or negative weights assigned to each tie or connection. And so a sign indicates the extent to which interactions between any two nodes are either positive or negative. And so assigned networks are quite helpful when we study, let's say, interactions in online communities, especially when people discuss controversial topics, because using this type of networks, we can judge the level of hostility both at the individual node level as well as at the group level. For example, at the group level, we can expect that connections between groups, subgroups tend to be more negative than internal connections within any particular subgroup. Let's consider this example of three users interacting with one another, John, Anne, and Mary. Without any additional information about the nature of the interactions, we don't really know whether these interactions were hostile or friendly. But look what happens if we assign labels, negative or positive signs to each connection. Then it gives us a little bit more information about what's actually happening in this network. For example, we see that interaction between Mary and John quite hostile, so it's between Anne and Mary. But John and Anne actually quite positive in their exchanges. This actually this configuration represents a well-known saying: "The enemy of my enemy is my friend." So in this case, if John, if Mary's enemy, then Anne, Mary is Anne's enemy, then John and Anne are friends. So this actually represents what we call structurally balanced network. When two individuals have positive ties with each other, they also maintain similar negative ties. And this is gonna in order to achieve what we call structural balance in the network. So if you have larger networks than 3 nodes, then you would try to count whether any 3 node configurations will have this structural balance. And in theory, if structurally balanced nodes will have odd number of positive ties. So here you have, out of 3 ties, you have 1 is positive. So that's balanced network. If you have all 3 connections positive, it's 3. It's also odd number of positive ties. And that in that case, the configuration will be considered locally balanced. And now if all of the 3 node configurations are locally balanced, then your whole network is structurally globally balanced. But of course, in reality, it's a bit more complicated and it's hard to achieve global structural balance. So if you look at the literature on this, there are different definitions of easier way to assess structurally balanced networks. Unfortunately, it's outside of the scope of this presentation, but there are lots of cool things you can do with this notion. What is important for us, though, is for this presentation, how do we go about labeling, assigning whether a connection is positive or negative? When we look at the previous literature, most of it really requires you to know whether or not people are friends already, or to know pre-existing positive and negative ties in the network. Unfortunately, when we're working with publicly available social media data, it usually gives us information about interactions. So whether people like something or retweet it, reply to each other. So that type of information doesn't really provide you information about relationship between people, whether or not they're friends. It doesn't really gives you by default whether interactions were positive or negative. So we really need to have some kind of automated way to look at interactions between individuals and judge whether interaction was positive and negative. Well, in our approach, what we suggest is to use toxicity scores produced using Google's Perspective API that we presented during the previous sessions to label exchanges as positive or negative. And so let me show you how we would do that based on a single interaction. So let's say we have this message tweet posted by the New Democratic Party leader, Jagmeet Singh. This is a federal party in Canada. And so essentially a tweet is about housing crisis, and where he says that the housing crisis isn't just an issue for cities, it's impacting Canadians across the country and so on. And so in reply to this tweet, there were a number of replies, but one of the replies was attacking Jagmeet Singh and calling him a religious extremist. And so if we were to run toxicity analysis on this data set of replies to a particular tweet, and let's assume that the toxicity score for this message is 0.8. So now we can use this score and we can assign it to this interaction, to this reply going from this user and the Jagmeet Singh account. So, so in a way, essentially, if we set the threshold for toxic interactions to be 0.8 or above, then we can say this connection going from this other user to Jagmeet Singh account is negative. So the key here, though, is because toxicity scores from Perspective APIs, they don't go from -1 to +1. So we don't have a natural division between positive and negative interactions. As we discussed before, we really need to establish a threshold where we know at what point an interaction we would consider for our research purposes interaction to be toxic, likely to be toxic or not. So if we set the threshold 0.8, any interactions, any messages, any replies with score equal or higher to that, we can treat it as negative tie. Otherwise, it will be positive tie. And we say positive tie, but in reality, it could be a neutral reply. So let's keep that in mind as well. How to set the threshold? It will really depend on your research questions and whether or not, if you do an exploratory analysis and you're trying to capture all positive toxic interactions, that perhaps setting a threshold to 0.7, a bit lower, makes sense. But if you're trying to adopt more conservative approach, then setting a threshold a bit higher, 0.8 or even 0.9, will reduce number of false positive results. But of course, you're likely to miss some other toxic messages that were scored a bit low. So this is an example, how do you assign a negative label, a positive sign to one single interaction. Now we can repeat this process for a larger networks where you have more interactions happening. Here's an example. So let's say you have tweets that are from or replies to a group of candidates that were running for political office. In this case, so the dots in the screen with labels indicate candidates running for who wants to become members of parliament in Canada during the 2019 federal election. All other nodes that don't have usernames, they were either replied to the candidates or candidates replied to them. So now this is what you would normally get from the communication network from Twitter. So yes, you can confirm by looking at this network that the candidates are central in this network, and that kind of makes sense. It's in fact the communication network, they're trying to reach out to potential voters and vice versa. But if we run the toxicity analysis, we will know whether some of these connections are toxic or not. So, and if once we set the threshold, let's say 0.8, we can then use colors to represent interactions that get the score 0.8 or above. So using, in my case, I use this pink-red color to represent those interactions that are likely to be toxic. So immediately you can see that one candidate, and this is was a candidate for the National Citizens Alliance of Canada, it's a small conservative party here, was getting the most number of hostile interactions here. I'm not going to read them out loud, but you can see this is just some of the examples of this red, pink color messages that the person was receiving. So you can see they're quite toxic. But we also see that from this visualization that toxic messages and trolls don't really discriminate based on one's party affiliation. For example, a cluster around a liberal candidate here, Andy Fillmore from Nova Scotia, also exhibit some toxic interactions, about half and half, I would say. Messages were civil and some were toxic. And so one of the nuances here that we know that such antisocial behavior towards politicians and other social media users are likely to discourage them from contributing to this digital public sphere in a meaningful way. Now that I demonstrated how we can turn regular communication networks and turn it into the sign networks and show you how it gives you more information about the nature of interactions, let me quickly show you how we can do it in Communalytic, because that's the whole point of developing systems like this, to make it easier for researchers like yourselves to take some communication networks and turn it into the sign networks. So I'm going to use an example from last week's session, from the session on Twitter data, where I have a data set replies to a tweet by Canadian Prime Minister Justin Trudeau about the World Environment Day from last month. And so essentially, I just pull all the replies and replies to that tweet using a Communalytic's Twitter thread import option. And so once I imported the data, it appeared under my data sets. You've seen that before. If you were to create a network in Communalytic right now, and you can do that, it will generate reply to network, but it will not have toxicity scores as part of the network. So you cannot really get signed network out of it. So first, keep in mind, you have to run toxicity analysis with your data sets to get those scores. And only after that, build a network. So this is just a reminder. We went through these main steps already. Once you received prospective API key, you just can start the analysis for this data set. Depending on the size of your data set, that may take a couple hours, or maybe even a day, depends on the size of your data set to run the analysis. For you, if you got just regular prospective API account, the speed of processing determined by this API will be about 50, 60 messages a minute. But there's a form Google gives you that you can apply for an increase allocation. So that will allow you to analyze 500, 600 messages a minute, so much faster. And so as a result of this analysis, as again, just a reminder, each message will get a score for multiple measures: toxicity scores, severe toxicity, insults, identity attacks, profanity, and threats. And the scores ranges from 0 to 1. And so you can see at the end is kind of summary for the whole data set, the average scores, the highest, lowest scores, and distributions for each score. So the toxic messages will be really on this right side of this distribution. And the threshold, again, will be determined by your research questions, so you can adjust it. If you export the CSV of the data set, each message will have this score attached to it in the Excel CSV file. But how do we go about attaching the toxicity scores to the network structure? So for that, we'll go to the network analysis part. So by clicking on the icon shown on the screen under the My Data Sets, it brings you to this network analysis interface. Then all you need to do is just hit Generate Network. The process of generating network will be much faster than toxicity analysis because it's done on our server on the backend. But it may take a minute, a few minutes. You can either wait, refresh your screen, or come back when it's ready. When it is ready, you will see 4 buttons in this on this page. The main button, we made it larger because that's what we expect you to do to visualize networks. The built-in visualizations uses your browser to visualize the networks, and we tested it with different network sizes. And so what we determined that it's most efficient if your network has 100,000 or fewer edges. So if you have very large networks over 100,000 edges, this option unfortunately will not be available because your browser is unlikely to be able to handle such network size. So for that purposes, you have 2 additional options. You can download the network structure discovered by Communalytic as a GraphML file. This is a very common format that is supported by many social network analysis programs, or a Gephi-specific format. And finally, you have this reset network file option. You might be wondering why it's there, what's the purpose? So it's there so that if you build your reply to network before running toxicity analysis, it will not have those toxicity scores built in. But later on, if you finish your toxicity analysis and you want to incorporate those scores into the network, what you want to do is you want to click reset the current network file and then rebuild it from scratch. So the reset network file, just to emphasize, will not delete your data set. It will only delete the network file associated with it, which you can rebuild. Next, once you hit visualize a network, it will open up within your browser, so you don't need to install any additional programs to see the network visualization of your data set. In our case, again, just a reminder, my data set contains replies to Justin Trudeau, Canadian's Prime Minister tweet. So as a result, you can see this expected configuration emerge. The node for his account, Justin Trudeau's account, is in the center of the network, appears to be larger in size, and the size represents by default in-degree centrality. Remember what Philip showed you, in-degree, out-degree centrality. So we chose by default to represent the size of the node to correspond to the number of incoming edges, which is corresponds to in-degree centrality. So as a result, Justin Trudeau's account appears to be influential because he received many replies. Then you have the second level of replies to replies indicated in this slide, and so on. To help you examine this visualized network, the visualization includes what we call control panel with multiple tabs. So let me just quickly go through main features of this control panel. So the first one is network properties tab, shows the number of nodes and edges in the network that you're visualizing. In our case, my network had 654 actor nodes, in this case, Twitter users, and 777, lucky number, edges, so connections. And connections in this case indicate replies. By default, we use a certain layout algorithm when the network is being built. On the backend, on the server, we essentially use layout algorithm to find where to display each dot, each node on this screen. And this is a time-consuming process. And in some cases, for dense networks, the default layout may not be the best option to visualize. So as a result, we added a feature for you within the browser to run additional layout algorithm. And in this case, it will be Force Atlas 2. So all you need to do if you want to kind of try to see if you want to improve visualization, click run for 3 seconds button, and it will essentially run this additional layout for 3 seconds. And it's an iterative process. In fact, you can click on this button as many times as you want, as long as you see that there's improvement in the visualization of the network. And by improvement, what we're looking for is the minimized number of overlapping connections between nodes. So when I apply this, so for this network, the default layout is pretty good already. I can see general structure of this network. But when I added this additional Force Atlas for 3 seconds, it actually made it even easier for me to see the core of this network around Justin Trudeau's account, as well as additional conversations are happening. The colors here I want to indicate, you can see this orange color here, then you have blue colors. Those colors I assign automatically. When we build in the network on the back end, we also running what we call community detection algorithm. In this case, it's the version of this community detection is applied called label propagation algorithm. What it does, it finds nodes that tend to interact with each other more often than with the rest of the network. As a result, you can see there are some nodes, like here, orange color nodes, that algorithm thinks that form their own subgroup, subcluster that may be worth examining. And if you want to examine each cluster identified by this algorithm one at a time, you can use this community cluster drop-down menu. The only thing that it will show clusters with 10 or more nodes in the network. If you have smaller network where each cluster has fewer than 10 nodes, this option will not be available. The additional filtering options here allows you to hide edges and nodes depending on either total degree centrality or toxicity scores. We'll get back to that in a second, but let me show you another feature that is we think it's quite useful, but also it's quite novel that is often not available in other platforms. So it allows you to view messages associated with connections represented in this picture. For example, we already see this orange configuration of nodes, and we see one node is larger in size, and we said that node size here represents number of in-degrees, number of other users replying to that user. So you might wonder, why that user is so actively being replied to. So what the visualization allows you to click on this node, and once you click on this node, in the control panel, under the Posts tab, you will see all the messages associated with this user. So you have a tab called From and To. So by default, you'll see there all the messages posted by the user that you selected, and there are 2 in this case messages. And you also see there's a tab 225, meaning that there are 25 other messages that people reply to that user. That kind of explains why that user has higher in-degree centrality. So by clicking on 2, you just can use this tab to scroll up and down to view these messages quite easily. There's also this icon here. It's a pop-up icon. Essentially, what happens is that if you collected data using Communalytic, either Reddit data or Twitter data. Or in 2 weeks, we'll talk about CrowdTangle, which is Facebook and Instagram data. So if you see this icon, pop-up icon next to the message, what it does, if you click on it, it will open a new tab in your browser, and it will actually show you the message as it was appeared in the platform at the time it was posted, if it's still available. So it allows you to explore messages in the as they were shown within the platform itself. But you don't have to. If you want to just quickly explore the content of the messages, you can use this built-in interface. Now, going back to this node and edge filtering option, remember I stopped at the community cluster drop-down menu. So the total degree centrality filter essentially allows you, if you scroll to the right, it will hide all the nodes that have fewer than specified number of incoming and outgoing connections. So it's a good feature to find most influential accounts in your network to kind of zoom in. But for the purposes of today's presentation, what we're really interested in is this toxicity score, because this is really how you can identify negative connections. Because remember, I introduced you to this idea of negative and positive connections, and the idea that we're going to use toxicity score to determine toxic interactions, and we call them negative ties. And so to actually visualize them in this built-in visualization, all you need to do is to scroll this bar to the right to set to the threshold that you determined for your research purposes identifies negative ties. And so if I say 70, which is, remember, the scores are from 0 to 1, but for simplicity, we project them to 100-point scores. So from 0 to 100%, kind of. So the 70 will be related to 0.7, essentially, on the original scale. So if you scroll to 70, all the edges with the toxicity scores less than 70 will disappear. So, and you can see that what you can see on the screen, those are likely toxic interactions. And so now, if you click on any of the nodes again, like this previous orange node we explored earlier. So if we click on that node again, we can see that messages appeared here is from 0, meaning that the user actually did not send any messages that considered it to be toxic. But out of 25 messages that the user received, 4 of them were toxic. And you can see I'm not going to read it, but the messages, I'm going to zoom in here. You can see they use profane language. So it's quite understandably that toxicity scores for these messages, for these interactions were quite high. And as a result, that's what you see in the screen. So now, once you conducted this exploratory visual analysis of your network within the browser, you probably generated some hypotheses and some research questions, and you're ready to analyze this network using additional social network analysis. So this is where you go back to your network analysis option, and you can download your files either as a GraphML or Gephi. And I just quickly see there's a question from Jamie in the chat room. Does this network diagram toxicity scores rely on toxicity analysis, so that I should only filter on toxicity after the toxicity analysis has completed? That's correct, and Philip confirmed that as well. So yes, if what happens, because toxicity analysis may take some time to analyze, so if you created this network visualization in Communalytic, this feature, this filter feature for toxicity scores will be disabled, and it will highlight that saying, hey, you haven't completed your toxicity scores yet, toxicity analysis yet. So you can start exploration of your network without the scores. And then if you rebuild the network after you finish your toxicity analysis, this filter option will be here. Yeah. So now, why would you want to export your network files and analyze it elsewhere? Well, it gives you a bit more flexibility to explore additional toxicity scores. The built-in visualizer only uses the most generic toxicity score, but there are other values you may explore, like identity attacks and profane language, or other severe toxicity scores. So that's something you can do once you export the file. You can also run additional SNA metrics at a micro macro level. So there's certainly an advantage of exporting. I'm linking here, and we will share the slides with the link to our preprint book chapter on how to use this type of analysis to analyze Reddit groups. And so you can see, depending on types of toxicity scores you use, these negative ties configurations may be quite different. So on the left side of this visualization, you have toxicity subnetwork showing connections that are toxic in this group. And you can still see for this group called Meta Canada, many connections are quite toxic. And that's essentially suggests that maybe toxicity, profane language is a norm for this group. But when we narrow down to another measure called identity attack, and we visualize those connections as negative ties, you can see there are a few of them. They are more clustered. And so essentially we can say that identity attacks are limited to fewer individuals and kind of essentially conducted by fewer individuals. And so then we can run additional network metrics like density, modularity, reciprocity. And so reciprocity, for example, shows you the percentage of reciprocal ties for each subnetwork. So for toxicity, if somebody send you a toxic message and you reply to it, you increase the reciprocity. In this case, it was 14% of times people will reply to toxic messages with toxicity. But when you're looking at identity attacks, only 6%, if you round it up, 7% of connections were reciprocal. So people were less likely to reply to identity attack with identity attack messages. So it really differentiates perpetrators of this type of attacks versus victims on the receiving end, and gives you a different dimension and additional research questions to explore. So to summarize, I showed you how we use toxicity scores to identify negative ties in the networks. And I showed you how you can use built-in network visualization in Communalytic to do the exploratory network analysis. Now I want to invite Alyssa Saifu, who will present you this next part, which will show you what you can do once you export the network file using third-party applications like Gephi. So over to you, Alyssa. I'm gonna stop sharing my screen.
Okay, hi everyone. Let me just make me full screen there. Can everyone see my slides and hear me? Okay, awesome. Yeah, thanks Anatoly for the introduction. So yes, my name is Alyssa and I'm a research assistant here in the social media lab. And going off of what Anatoly just presented, so he talked a bit about the built-in network visualizer on Communalytic. I'm going to talk today about Gephi. So this is a social network analysis software, and I'm going to talk just about how you can use Gephi, some of the things you can, research questions you can answer with Gephi. And to demonstrate some of those things, I'm going to be using examples from a project I worked on in the social media lab where we analyzed Twitter data using Gephi and social network analysis techniques. So yes, as I mentioned, Gephi is a software that is commonly used for social network analysis. It is open source. And because of that, it's of course very easily accessible. It is free, which is amazing. And it also works on both Mac and PC. While I am gonna, as I mentioned, go through some examples of how you can use Gephi and go through some of the instructions and kind of walk you through some things, going into any more detail than what I'm going to go in today is a little bit outside the scope of this workshop. But the great thing is because this is an open source platform, there are a bunch of tutorials and a lot of resources online. So for example, even just on the Gephi website, I think I have that linked here when you get the slide deck. But just even on the Gephi website, there are tutorials that are very informative and introduce you to some of the basic features of the software. YouTube as well, you can learn how to do anything on YouTube, is also a great resource. And I also just want to mention that it is very user-friendly. I started using Gephi when I started in the social media lab in September, and it was very easy to pick up, just using the available resources, and of course with guidance from Anatoly as well. So as I'm going through my presentation today, you'll see that a lot of the tools and a lot of the things that I'm going to talk about are similar to what Anatoly has just talked about with the built-in visualizer on Communalytic. The difference is, as Anatoly mentioned, in Gephi, you can analyze bigger data sets, and there are also just more things, it's more powerful. There are more things you can customize in your analysis. Because of that, again, as mentioned, it might be a good idea. What we suggest is you get your data from Communalytic. You might explore that in the built-in visualizer, come up with some research questions, and then you can use Gephi, and I'll show you some things you can do today, but to then further investigate those research questions. One of these additional features that I'm going to talk about today is the data laboratory feature in Gephi. So it's kind of set up like an Excel spreadsheet and has many of the same capabilities. So you can sort by different variables, filter, and things like that. And I'll talk a bit more about that. So as I mentioned, I'm going to be using some examples from a project I worked on, which was an analysis of public replies on Twitter to COVID-19 related tweets from both Donald Trump and Joe Biden. So it's actually two separate data sets in this analysis. And we, of course, collected this data using Communalytic and exported it using Communalytic, as Anatoly had kind of gone over there. I'm not going to talk about that, but of course, you can see the previous sessions, and there are also tutorials on Communalytic itself. Our main research question was to investigate if we see, so we know that the supporters of both of these leaders, there's a divide between them that has really only deepened since the 2016 election and further during the pandemic. So we wanted to see if we would see this divide reflected in these two different networks surrounding replies to each of these tweets. A little bit of background about each of these tweets. So the Donald Trump tweet, this was a video he tweeted out after he was released from the hospital after his COVID-19 diagnosis. And he was in this video just really downplaying and not taking it too seriously at all. On the other hand, in contrast, we had Joe Biden with this tweet, who is essentially calling out Donald Trump and his administration. And as he says, he's alarmed by how dire the situation with COVID had gotten in the US at the time. And just to take a step back and talk a little bit about the bigger picture and the kinds of questions you can answer with social network analysis. In this case, we weren't just interested in the users in this network. We weren't just interested in, who was sending tweets and replying to these messages. We also weren't just interested in what the tweets were. We were really interested in the connection between the two. So who was sending what tweets and what were the connections? Who was tweeting to who? And things like that, the relationships between the two. So that's what social network analysis is really great for. And I hope that, you can think about some of the ways that you could use it in your own work. So now I'm going to get into some of the more specific steps about how to analyze data in Gephi. I'm not going to go into too much detail, just going to a brief overview, but you can check out the link to the blog post, which will be on the slide for more detailed instructions. Okay, so when you first download your data set and import it to Gephi from Communalytic, you're essentially just going to have a big clump of nodes. It's not going to look really meaningful at all. You're not really going to be able to see anything. And to make this easier, the first thing you can do is apply a layout algorithm. So as Anatoly mentioned, the general idea here with when you apply a layout algorithm is that it kind of goes in and it pulls apart the nodes and edges and arranges them in a way that will reduce the visual clutter in your data set and just make everything, make it easier to see what's going on in your network. Again, as we saw with the built-in visualizer in Communalytic, this is applied by default. I believe it was Force Atlas 2 that is applied by default in the built-in visualizer. In Gephi, you do have to apply this manually, but there are different options for the actual layout algorithm you can apply. So in our data set, we did the Futurman-Reingold data set layout algorithm, and there's also OpenORD. That's one that's good for larger networks. But like I said, there's a bunch of different options, and I would just recommend when you import your data set to Gephi, it's really easy to try out different ones and just see which one works best for you to reduce that visual clutter. The next thing you can do in Gephi is you can change your node size. So again, in Communalytic and the built-in visualizer, the default is that node size is representative of in-degree centrality. So in that case, larger nodes represent users who receive more replies. In Gephi, you can customize this. So in our case, we changed our node size to represent out-degree centrality. So in our network, larger nodes were representative of users who replied more to other users. But again, there's other options as well. So for example, if you are analyzing a Twitter data set, you can use any of the variables that are collected in Communalytic through that. So for example, followers. So you can set up your node size to represent, make it representative that larger node size nodes would represent users with more followers. Third, you can change your edge color. So as we know, when you collect data in Communalytic, you can do the toxicity analysis. So we changed our edge color to represent the general toxicity score, which is between 0 and 1. And that is automatically, when you run the toxicity analysis, applied to each edge in your data set. So we particularly used a gradient. So we picked our toxicity threshold, which was 0.8 based on some of our previous work. And we set it up so that approximately, maybe 0.8 would be around here on the scale. Edges with a toxicity score above 0.8 would be red, and anything below that would be green. So we could visually very easily see, which edges are likely toxic and which are not. Again, with the customization options here, we just chose to go with the general toxicity score, but you can also use any of the other scores that are assigned in Perspective API. So you could do, if you're interested in like identity attacks, or you can use the severe toxicity. It really just depends on what you're interested in looking at. So once you do those 3 steps, this is when we did those, this is the 2 different network visualizations that we got. And as you can see, it's really easy to take a look at both networks and look for differences or similarities between them. So in our case, as we discussed, we were kind of expecting to see, or we wanted to investigate if we saw that divide between party reflected in differences in the structures of both of these networks. And as you can see, we don't really see that. They're both structured quite similarly. If these labels weren't here, it would be kind of hard to tell, which network is surrounding which of the tweets. They both demonstrate a core periphery structure. So that's when you have the original tweeter in the center. So in this case, you would have Joe Biden in the center. You have the inner periphery, which is just replies directly to Joe Biden. And then on the outer periphery, you would have replies to those replies. So you see that structure in both of the networks. Additionally, because we set up our network so that green edges are non-toxic and red edges are going to represent likely toxic replies, you can also see just by looking at the color distribution, essentially, that it doesn't seem that one network really has significantly more red edges than the other, or significantly more green edges. What that kind of leads us to observe is that it seems that toxicity is distributed equally and similarly in both of these networks. The other thing we can start to see once we're just taking a look at this overall network visualization is you can start to see areas of interest. So you can start to see, for example, maybe areas where there's a lot of red edges, so there's a lot of toxicity centered around a particular node. You can start to see some of the larger nodes, so users that are more active, they're sending a lot of replies. And I'll talk a bit more about what some of these areas of interest mean, but first let's talk about when you identify those areas, how can you go about investigating those more in Gephi? So as I mentioned, the data laboratory feature in Gephi is great. So this is where that comes in. So when you identify an area of interest, let's say a particular node you want to investigate further, or a particular user in this case, you can right click on that node in Gephi and select that node or user in the data laboratory. When you do that, when you go over to the data laboratory tab, that user or that node is going to be highlighted. You can then right click again and select related edges. And remember, in our case, edges are replies. So what you're going to get as a result is you're going to get all of the related replies to that particular user. You can distinguish between which tweets were either sent or sent to that user through the source and target columns. And you can also see the actual content of the tweet through the text column. So you can go and investigate, what kinds of things is this user saying? What kinds of things is that user, are being said to that user? You can also find out their Twitter handle and then manually go over to Twitter. And as long as that user is not suspended or deleted their account, you can look at their profile. And that's what we did in this case. We would go and investigate particular nodes or users of interest, and we would try to get a sense of, is this person frequently tweeting or retweeting in support of one particular leader, to try and, just figure out more about who this user is. I want to note as well, so as Anatoly demonstrated, this is done pretty easily in the built-in visualizer. You can just essentially click on a node and very easily see, tweets that were sent to a particular user. Nonetheless, you can also do this in Gephi, so I just wanted to also show how you can do that. So now getting into some of these areas of interest, and I want to make sure I'm clear that what these areas of interest are in your data set and what they mean is all going to depend on how you set up your network. So in our network, for example, we set up our network so that larger nodes would be users with higher out-degree scores, so users that were sending more replies. On the other hand, though, if you had set up your network for in-degree, for node size to represent in-degree centrality, then larger nodes are going to represent users that are receiving more replies. So it really all just depends on how you set up your network and what you're interested in investigating. So like I said, in our case, larger nodes were users that were sending more replies. So we identified this particular user here, and we went through those steps I just mentioned of, going into the data laboratory tab and further investigating this user. The first thing we can see just from visually looking at this node in the network is that, so it's a larger node, and you can also see that the edges surrounding them, the arrows are pointing away. So this confirms that this is a user who is replying a lot to others, but is not receiving many replies. Also, just from looking at this node and the surrounding edges, we can say, maybe about half of them are red, which maybe says that about half of them are toxic. This is, of course, just a kind of a rough visual estimate. And if you did want a more accurate estimate of, exactly what percentage of this user's replies are toxic, there is a way to do that in the data laboratory tab. I do go over that in the blog post. So if you want more details on that, you can check that out. But yeah, so when we investigated this user both on Twitter and some of the things that they were saying, what we observed was that this user seemed to frequently tweet or retweet things that were in support of Donald Trump. And some of the edges that were included in this network, they were, as you can see from some of these examples, just really not taking the COVID that seriously. So that was one of the things we observed. Another type of area of interest that we identified were attacks, essentially. So this is when we would see a smaller node surrounded by a lot of edges. So, and often, as you can see from these examples, a lot of red edges. So this kind of indicates to us that because it's a smaller node, they're not the ones that are sending a lot of messages. And then as well, because it's, many red edges, they're receiving a lot of toxicity. And again, going through those steps of, investigating these nodes in more detail and, some of the messages they were receiving, what we observed is that in both networks, both users who seem to be in support of Donald Trump or in support of Joe Biden, both were on the receiving end of toxicity. So again, even though we, supporters of both leaders, they think that the other side is so different, it doesn't seem that in terms of receiving toxicity that there's any discrimination there. They both receive relatively the same amount of toxicity in these networks. And then the final thing that we did in our analysis is we also looked specifically at the most toxic accounts in our data set. So just to clarify, the kind of areas of interest and things I was talking about before, this was based on all the replies in our networks. We did set up our, if you'll recall, the gradient so that our edges, we could see which edges are likely toxic or likely not toxic, but still that was based on all replies. If you did just want to look at only just the toxicity in the network, there's a way to do that. And it involves applying a filter to filter out any non-toxic edges from the network. You can do this in the filter tab. And again, just you base it on your toxicity threshold. In our case, it was 0.8. The next thing you have to do is in the statistics tab, you have to calculate in degree and out degree centralities. And it's important that you do this after you have filtered out those non-toxic edges so that you're calculating these scores based on just the toxic edges. If you do this calculation before, you're not really going to actually be investigating just those most toxic accounts. So that's why it's really important that you do it after. And like I said, that's in the statistics tab, and you just run the average degree function. After that, you can go over to the data laboratory again. And like I mentioned, very similar to an Excel spreadsheet. And you can actually just sort your list by either in degree or out degree, depending on what you're interested in. So for example, in this screenshot, you can see it seems that this is sorted by in degree. So this means that users at the top of this list, they are users that are receiving a lot of toxic messages in this data set. And then if we had sorted by out degree, that would be users that were sending a lot of toxic messages. So yeah, those are some of the things that I did in this particular analysis. And this is really just the tip of the iceberg when it comes to social network analysis and social network analysis in Gephi. As Philip mentioned, there's a whole other set of things you can investigate, those macro level characteristics. But nonetheless, this is just, like I said, a quick introduction to hopefully get you guys interested in doing social network analysis. Great, thank you.
Thank you, Alyssa. And now we have time for your questions. I will stop the recording, and we actually have about 20-25 minutes for the Q&A part. Just to remind you that in 2 weeks, we're going to have our last 6th session, and we will talk about another type of networks that may be useful for your research. We call them two-mode semantic networks. And so we will use examples and data sets from CrowdTangle, which allows us to collect public data from Facebook groups, pages, or Instagram accounts. And so we'll show you how to discover and use two-mode semantic networks. But in the meantime, I'm going to stop the recording and open floor for your questions.